Hello everyone, welcome to Lighthouse Project Season 3 Large Language Models. Today we will discuss a topic that sits at the intersection of cutting-edge AI innovation and practical applications. Large language models at the edge, challenges and promises for real-time intelligence. Large language models are among the most transformative AI technologies of the decade, enabling natural language understanding, generation and interaction at unprecedented scales. They've reshaped how we think about AI applications across industries. There are three primary approaches to deploying LLMs for edge applications. Cloud edge. Processing is distributed between cloud servers and edge devices, with the cloud handling complex computations and edge devices handling lighter tasks. Cloud edge client, a more distributed model where computation is shared between the cloud, edge devices, and user devices, optimizing both performance and resource usage. Edge only. The most autonomous approach, where all computations occur directly on the edge devices, ensuring low latency and maximum data privacy. To understand the impact of edge LLMs, let's first look at how they are revolutionizing personal applications. Mobile automation has evolved into an essential domain for applying edge large language models. By leveraging their ability to process natural language and adapt to context, tools like AutoDroid, LlamaTouch, and AppAgent are simplifying complex workflows and significantly enhancing productivity. AutoDroid stands out as a revolutionary tool for Android automation. It dynamically analyzes apps and combines common-sense reasoning from large language models with domain-specific insights. For instance, it can automate routine tasks like scheduling appointments or ordering food, eliminating the need for user input. LlamaTouch is a scalable testbed designed for mobile UI automation. It allows researchers to simulate real-world app interactions, while providing detailed annotations for every UI component. This setup enables advanced mobile agents to seamlessly navigate and perform tasks, such as managing calendar entries. AppAgent mimics human behavior on smartphones, performing tasks like email drafting or photo editing with a multimodal approach. It integrates visual and text data to improve its understanding of user intent, making smartphone interactions intuitive and effortless. While mobile automation has seen dramatic improvements, wearable and AR/VR systems are also benefiting from the integration of edge large language models. Edge large language models are transforming wearable devices and AR/VR systems, enhancing user interactions and delivering real-time insights. These innovations improve functionality while preserving privacy by processing data locally. OD Search introduces a powerful on-device search engine tailored for fitness trackers and other wearables. Users can interact with their health data using natural language, asking questions like, "What was my average heart rate last week?" It processes these queries in real time, ensuring both privacy and responsiveness. OWL is a concept for always-on wearable devices that redefine memory augmentation and proactive life assistance. Imagine a device that not only reminds you of important tasks, but also summarizes your day's activities or suggests actions based on patterns it observes, all while ensuring data security. Tricy stands out as a lightweight framework for context-aware text generation. It integrates large language models with trigger-guided training to produce personalized outputs, such as generating actionable summaries during meetings or adapting responses for unique user needs in AR/VR environments. Building on these personal innovations, enterprises are now leveraging edge large language models to tackle challenges in automation, privacy, and productivity at scale. In enterprise environments, edge large language models are transforming software development by automating complex and repetitive processes. By integrating advanced natural language understanding, these tools simplify tasks that were traditionally time-consuming, enhancing efficiency and accuracy. Privacy-preserving tools powered by edge large language models provide secure and efficient solutions for enterprises by processing sensitive data directly on edge devices, such as smartphones, IoT hubs, and local servers. Unlike cloud-based systems, edge deployment ensures that data remains local, minimizing the risk of exposure during transmission and enhancing privacy. This is particularly critical in industries like finance, healthcare, and legal services, where regulatory compliance and data security are paramount. Crash Translator, on the other hand, automates one of the most frustrating tasks in debugging, reproducing crashes from stack traces. It analyzes error logs and simulates the conditions that led to the crash, allowing developers to identify the root cause with precision. For instance, if a mobile app crashes intermittently on a specific device, Crash Translator can recreate the environment locally on a developer's edge device, pinpoint the issue, and suggest potential fixes. By eliminating much of the trial and error traditionally involved in debugging, Crash Translator shortens debugging cycles and accelerates time to market. Privacy-preserving tools powered by Edge large language models provide secure and efficient solutions for enterprises by processing sensitive data directly on edge devices, such as smartphones, IoT hubs, and local servers. Unlike cloud-based systems, edge deployment ensures that data remains local, minimizing the risk of exposure during transmission and enhancing privacy. This is particularly critical in industries like finance, healthcare, and legal services, where regulatory compliance and data security are paramount. Private GPT is a prime example of leveraging edge devices for secure NLP tasks. It allows users to query sensitive documents directly on their local devices without any internet connection. For instance, a financial analyst can analyze confidential reports or perform Q&A tasks on proprietary data, all while ensuring that sensitive information never leaves the device. By running entirely on the edge, Private GPT safeguards privacy, reduces latency, and complies with strict data protection regulations. Similarly, GPT-4All is an open-source ecosystem of lightweight chatbots optimized for edge deployment. These models run entirely offline on edge devices, such as local workstations or secure enterprise terminals, enabling tasks like customer support, internal knowledge management, and document summarization. Enterprises benefit from reduced cloud dependency and gain complete control over their data while maintaining operational efficiency within organizational boundaries. By running privacy-preserving tools on edge devices, enterprises can unlock secure real-time intelligence without compromising user trust or data integrity. Having explored how edge large language models are revolutionizing enterprise software development and privacy-preserving NLP, let's now shift focus to the industrial sector, where they are enabling groundbreaking advancements in robotics, autonomous systems, and real-time data processing. Large language models are revolutionizing human-robot interaction by enabling robots to understand contextual language commands, interpret user intent, and execute tasks seamlessly. These advancements are making robots more intuitive and adaptable, transforming them into effective collaborators in industrial settings. RoboClean is specifically designed for low-resource environments where robots need to operate autonomously without extensive computational resources. For example, in a factory, RoboClean can interpret contextual instructions like clean the chemical spill near the conveyor belt, ensuring safety and operational efficiency. By leveraging LLMs, RoboClean bridges the gap between human language and robotic actions, enabling robots to handle complex scenarios that require precision and contextual understanding. Mobile Robot focuses on enhancing human-robot collaboration in mobile robotics. It enables robots to interpret nuanced commands, such as adjusting their pace, rerouting paths, or slowing down to align with a worker's movements. For instance, in a logistics warehouse, Mobile Robot can adapt its route based on real-time changes, like a blocked aisle or a worker crossing its path. These advancements make robots safer and more productive collaborators, improving efficiency and reducing the risk of accidents in manufacturing and logistics environments. These innovations in human-robot interaction are powered by edge-deployed large language models. By processing commands locally on edge devices embedded in robots, these systems eliminate latency issues and ensure real-time responses. This is especially crucial in environments like factories or warehouses, where reliable and autonomous operations are critical. Edge deployment also enhances privacy and reduces reliance on constant cloud connectivity, making these solutions more robust and efficient. Beyond human-robot collaboration, edge large language models are also transforming real-time data processing in industrial applications. From analyzing sensor data to optimizing operations, these models enable industries to harness actionable insights in time-sensitive scenarios. Otter is an end-to-end system specifically designed to simplify embedded sensor data collection and analysis using large language models. It supports seamless data acquisition on commodity embedded platforms and employs a natural language interface for interpreting the collected data. For example, in a manufacturing setting, Otter can monitor multiple sensors tracking equipment performance, such as temperature, vibration, or pressure, using natural language queries like, "What's the status of the conveyor belt motor?" or "Are there any anomalies in the temperature data from the last 24 hours?" Otter can provide immediate insights into operational efficiency. Additionally, it can detect potential issues like overheating or wear and tear, enabling proactive maintenance. BERT-FTL is a lightweight text recognition model that is optimized for resource-constrained devices. It specializes in processing industrial reports, logs, and documentation in real time, providing actionable insights. For instance, in a remote industrial site, BERT-FTL can analyze maintenance logs to predict equipment failures by identifying patterns in reported issues. For example, it can highlight recurring warnings about a pump's performance or identify inconsistencies in operation logs. Its low power consumption and high accuracy make it ideal for environments where connectivity to the cloud is limited or unreliable. By processing data locally, BERT-FTL enables factories to operate more efficiently and reduces the dependency on centralized infrastructure. These tools, Otter and BERT-FTL, illustrate the transformative potential of edge-deployed LLMs. By processing data locally, they eliminate latency and provide real-time insights, even in connectivity-limited environments. Furthermore, edge deployment enhances privacy and reduces the need for costly cloud infrastructure, making these solutions scalable and accessible for industries of all sizes. Now that we've explored innovations in industrial applications, let's examine real-world case studies showcasing how edge-deployed large language models are solving pressing challenges across industries. Let's start with NVIDIA Jetson. NVIDIA provides a proven platform for deploying compact large language models like GPT-J for natural conversational AI. The platform has been used successfully in smart home assistants, where commands are processed locally to deliver real-time responses with minimal latency. For example, a Jetson-powered assistant can adjust lighting, check the weather, or play music based on voice commands, all processed on the device itself. This local processing ensures quick response times and enhances user privacy by keeping sensitive data on the device. Similarly, in customer service bots, Jetson's low latency processing allows seamless interactions, improving user satisfaction by avoiding delays caused by cloud processing. Tesla's full self-driving systems use edge-based natural language processing for real-time voice commands. This capability allows drivers to interact with their vehicles without relying on cloud connectivity. For example, drivers can issue voice commands like navigate to the nearest charging station or play my music playlist, and these requests are processed locally by Tesla's proprietary hardware. This ensures fast and reliable performance even in areas with poor network coverage. Tesla's full self-driving systems demonstrate how Edge NLP can deliver seamless, privacy-preserving user interactions by processing data entirely on the vehicle. OpenAI's Whisper is a breakthrough automatic speech recognition model that has been deployed on edge devices such as RISC-V processors and TPUs. This system enables real-time transcription and voice command processing entirely on local hardware. In healthcare, Whisper is used to transcribe doctor-patient conversations in real time, ensuring accurate documentation while maintaining patient confidentiality by keeping data on the device. In industrial environments, Whisper powers hands-free operations. Workers can use voice commands to control machinery or generate real-time logs, enabling more efficient workflows. By processing data locally, Whisper ensures privacy and eliminates the latency typically associated with cloud-based solutions. The Qualcomm Snapdragon AI engine has successfully enabled on-device inference of large language models for various mobile applications. Snapdragon chips used in billions of devices provide the processing power necessary for real-time applications like text prediction, translation, and voice interaction. For example, Grammarly utilizes LLMs on Snapdragon-powered devices to provide real-time grammar suggestions directly on smartphones. Similarly, Google Translate performs on-device speech-to-text and real-time translation, enabling seamless communication without relying on constant cloud connectivity. These implementations highlight how Snapdragon chips improve speed, reduce latency, and enhance privacy by processing data locally. AWS IoT Greengrass has demonstrated the ability to deploy large language models on IoT devices for edge intelligence. In precision agriculture, for example, edge LLMs analyze sensor data related to soil health, weather, and crop conditions to provide actionable insights for anomaly detection and predictive maintenance. In industrial robotics, IoT Greengrass powers autonomous devices to process tasks such as identifying operational inefficiencies or detecting maintenance requirements in real time. By running LLMs directly on IoT devices, AWS ensures that operations continue efficiently even in environments with limited cloud connectivity, reducing reliance on external infrastructure. Siemens Healthineers has implemented GPT-based solutions for predictive maintenance in diagnostic systems, ensuring uninterrupted operation of critical healthcare equipment. Their smart remote services platform uses edge large language models to monitor the performance of medical imaging devices. When anomalies are detected, the system provides real-time alerts to technicians, enabling proactive maintenance before a breakdown occurs. This proven solution minimizes downtime, reduces repair costs, and ensures reliable diagnostic services even in regions with limited connectivity. Schneider Electric has deployed edge large language models to optimize smart grid operations. Their systems analyze real-time energy consumption patterns and predict demand surges, allowing utilities to adjust distribution autonomously. For instance, at local substations, edge LLMs adjust energy flow parameters to prevent overloads and improve efficiency. This ensures reliable energy delivery while reducing waste. By processing data locally, Schneider Electric has reduced its dependency on cloud infrastructure, resulting in faster, more cost-effective, and sustainable solutions. These examples showcase how edge-deployed large language models are already transforming industries by enabling real-time intelligence, improving efficiency, and maintaining privacy. From smart home assistants and IoT devices to healthcare diagnostics and energy management, these proven applications highlight the practical impact of edge LLMs in solving real-world challenges. Next, let's discuss the challenges and opportunities in deploying these systems and how we can address them effectively. While the potential of deploying large language models at the edge is immense, it is not without its challenges. These challenges span across hardware limitations, latency concerns, security and privacy issues, and energy efficiency. Let's examine each of these in detail to understand the barriers we need to overcome to fully unlock the potential of edge large language models. Edge devices, such as smartphones, IoT sensors, and edge gateways, have limited computational power compared to centralized data centers. Running large-scale large language models on such devices poses significant challenges. Unlike cloud-based systems with high-performance GPUs and TPUs, edge devices often rely on low-power processors. This makes it difficult to handle the computational demands of large language models, especially for real-time applications. For example, tasks like natural language understanding or generating context-specific outputs require billions of parameters to be processed, which is beyond the capacity of most edge hardware. Large language models are massive, often requiring gigabytes of storage just to load the model. Many edge devices have limited memory, making it impractical to run these models directly without optimization. This is why techniques like model pruning, quantization, and knowledge distillation are essential to adapt large language models for edge deployment. Beyond hardware constraints, latency and real-time processing are critical challenges for edge applications. Edge applications such as autonomous vehicles or real-time transcription services demand ultra-low latency. Any delay in processing can compromise functionality and, in some cases, safety. For example, an autonomous vehicle processing a stop sign must respond within milliseconds to ensure safety. Delays caused by computational bottlenecks can lead to critical failures. Similarly, in healthcare, real-time transcription or diagnostics must process data immediately to assist doctors in time-sensitive situations. Many edge systems rely on intermittent connectivity to the cloud for additional processing. This reliance introduces latency due to network delays and increases vulnerability in environments with limited connectivity. Eliminating these delays requires maximizing on-device processing while minimizing dependence on cloud communication. Latency aside, the challenges of maintaining security and privacy at the edge are equally critical. One of the key advantages of edge large language models is the ability to process data locally, reducing the risks of data exposure. However, this also introduces new challenges in ensuring security and privacy. Processing sensitive data locally reduces risks of exposure during transmission, but storing and encrypting this data securely on devices remains a challenge. For instance, wearable health devices analyzing patient data must prevent unauthorized access or tampering while maintaining privacy. Large language models need to ensure their outputs are not biased or harmful. This is particularly crucial in applications like customer support or legal assistance, where accurate, unbiased responses are essential. Additionally, transparency in how these models process and store data is necessary to build trust with users and comply with regulations. Security and privacy challenges are compounded by the energy demands of running large language models on edge devices, which leads us to the next challenge: energy efficiency. Energy efficiency is a critical concern for edge large language models, especially in battery-powered devices like smartphones and IoT sensors. Inference with large-scale large language models consumes significant energy. For example, running real-time speech recognition or translation on a smartphone can drain its battery quickly. Edge devices in remote areas or industrial settings may have limited power supply, making energy optimization crucial. The high energy consumption of large language models conflicts with sustainability goals. Running energy-intensive models in large-scale IoT networks or smart cities can increase their carbon footprint. To address this, research is focusing on hardware-software co-design, such as developing energy-efficient chips and optimizing model architectures. While deploying large language models on edge devices presents challenges, it also opens the door to incredible opportunities. Advancements in hardware, privacy-preserving techniques, expanding applications, and trustworthy AI are paving the way for the next generation of edge intelligence. Let's explore these opportunities step by step. One of the most exciting opportunities lies in hardware advancements. Emerging AI accelerators, such as TPUs, RISC-V architectures, and neuromorphic chips are making LLM inference more efficient and accessible. Take neuromorphic chips, for example. These chips mimic the way human brains process information, enabling energy-efficient computation for complex tasks. Such advancements allow edge devices to handle large-scale models while reducing power consumption. These developments are not just theoretical. Companies like Google, Nvidia, and Intel are already pushing the boundaries with AI-specific hardware, making it possible to run sophisticated large language models on compact devices. Privacy-preserving techniques are another critical area of opportunity. Tools like federated learning and local inference ensure that sensitive data never leaves the device. For instance, federated learning enables edge devices to train and update models collaboratively without sharing raw data. This approach is particularly valuable in sectors like healthcare, where patient data must remain private. Additionally, by processing data locally, edge devices can reduce the risk of data breaches and ensure compliance with regulations like GDPR. This dual focus on privacy and performance makes edge large language models a compelling solution for security-conscious industries. Edge large language models unlock immense potential for real-time applications across a variety of domains. In healthcare, for example, edge devices equipped with large language models can assist with real-time transcription during consultations, or even analyze diagnostic data to provide actionable insights. In autonomous systems, edge large language models enable vehicles to understand and process complex voice commands or natural language navigation instructions without relying on cloud connectivity. And in robotics, large language models are being used for human-robot collaboration, helping robots interpret contextual language commands and perform tasks more intuitively. These expanding applications highlight how edge large language models are reshaping industries by providing faster, more secure, and localized intelligence. Finally, the development of trustworthy AI is an essential opportunity for edge large language models. By focusing on secure, explainable, and reliable AI systems, we can build user trust and meet regulatory requirements. Explainable AI, for example, helps users and stakeholders understand how large language models generate responses, ensuring transparency and reducing biases. This is particularly important in fields like finance or legal services, where accountability is key. Moreover, secure AI models can prevent misuse and safeguard sensitive data, addressing the growing concerns around cybersecurity and ethical AI deployment. By prioritizing trustworthiness, edge large language models can not only gain broader adoption, but also contribute to responsible and sustainable AI practices. That's all for today. If you enjoyed the video, don't forget to give it a thumbs up and share it with your friends. And if you haven't already, hit that subscribe button and turn on the notification bell so you never miss an update. I'd love to hear your thoughts, so drop a comment below. Thanks for watching, and I'll see you in the